So, in chapter 4.5, we are going to talk about how to basically outline an experiment. So, today we're going to show you how you outline it, how you talk about it, and I'll emphasize what we'll want to make sure that you know how to do on the exam. But when we do an experiment and we lay out an experiment well, a couple of things that you want to make sure that you do. Okay? First thing that you want to make sure that you do is you have some sort of random assignment. Okay? So basically, your experimental units are going to be assigned to groups which receive the treatment, and they are assigned in such a way that they are equally likely to participate in any of the treatments. Okay? What we want to try to do, or one specific experimental design, is called a completely randomized design. That's where basically every single treatment are assigned to all the experimental units or your subjects by chance. So each experimental unit or subject has an equal likely chance of being assigned to one of the various treatments. So yesterday when we were talking, we had like two different experimental designs that had each 6 treatments in them. Whether it was based on, diet and exercise programs, or like with the tomatoes, it was dealing with water and fertilizer. So when you assign those tomato plants or those subjects to those treatments, they need to have an equally likely chance of being selected. So, one of the things that we like to do is to show you how you can use basically a flow chart to outline a completely randomized design and what it will look like. Okay? So when you do a experiment and you want to show how you would conduct it, or at least give an outline on how you would conduct it, this is what we would look for. You first start off by noting how many people are in, or subjects or experimental units you have. So here it says below is an outline. If we were doing an experiment on 50 students, and we're doing some sort of experiment where we are comparing online versus classroom instruction. We're wanting to see if you students learn better under online instruction versus classroom instruction. So again, the first thing you want to do is note your experimental units or your subjects. Then, what you actually want to say second is you actually want to say the words random assignment. So you know that specifically we are going to assign these students to one of however many groups you need based on how many treatments you have. Here we have 2 treatments. Either they're going to be assigned to the online instruction or to classroom instruction. So we're going to assign 2 groups of 25 students. So you'll start off by saying group 1, 25 students, group 2, and tell how many are assigned to each group. You want to assign them equally if possible. It doesn't have to be perfect, meaning if I had 49 volunteers, if you said one group had 25 and the other has 24, that would be okay. So there will be times where you might not be able to do it perfectly. You might have 100 students and you might have to have 3 different groups. So you might go 33, 33, and 34. Then you choose one of the treatments for one of the groups and the other treatment for the second group. Finally, at the end, you'll draw arrows to what you're going to measure. So this is basically your response variable. Okay. So you're going to tell us what are you going to compare? What are you going to look at? Okay. So here they didn't give you a specific descriptor, but here it says compare SAT scores. We might, it should in the problem somehow tell you what your response variable is. Now, once in a while in an experiment, okay, they might not do some comparisons. Like here we're comparing two different groups. They might want to say, does, taking a certain type, does drinking caffeine keep you awake longer? More than likely it probably does. So, to measure that, you'd have to measure it against another type of group to see if there's actually an improvement. That type of group is what we call a control group. It's a baseline group, right? Basically provides a group to compare the effects of the other treatment. One of the examples that I've always liked to use in the past was basically an observational study, or you can almost kind of think of it like an experiment, even though there's more variables out there that can be controlled, where a graduate student did an experiment and looked at how does listening to certain types of music, how can that affect or impact learning? Is there an association with the type of music you listen to and your learning habits? So what the psychology grad student did was he took a set of lab rats, okay, did a random assignment to one of three groups. He had one group listen to classical music, he had one group listen to heavy metal music by the band Anthrax, and he had one group not listen to music at all. That group that wasn't listening to music at all was basically his control group, his baseline group. Okay. So what he did was he had these rats that were assigned to the groups. He wanted, though, to make sure, and this is why it wasn't a complete random sample, but in each of the three groups, he had the rats run through the maze without listening to any music to find out how long it took them to run through the maze. Then each group had an average of about 10 minutes, okay, of their grouping of rats. So each day he'd have each group of rats practice running through the maze, listening to their music for an hour. After a period of time, and I don't remember how long, if it was 1 week, 2 weeks, or a month, or however long it was, he collected his results and made the comparison. The baseline group, from practicing not listening to any music, went from 10 minutes to 5, so they had improved learning. So that's the baseline. They cut their time in half. Okay. The group listening to classical music cut their time from 10 minutes down to, guess what? How many? They actually cut it down to 1 minute.
What?
Yeah. Guess what the Anthrax mice did?
20 minutes.
Yes. They went the opposite direction. Okay? So, but it gave them a chance to compare. And the reason why I like to bring that up is it talks about how a control group can be used. Now, like in this experiment, you wouldn't necessarily need a control group with this classroom, because classroom instruction is the traditional method. We're going to see, does online actually do better than classroom? So we don't necessarily need a control group. Sometimes you do, sometimes you don't. So, now, the other important tip, okay, and I'll show you how to do this, but at least for our regular stats classes, on our exam, I won't require you to do this part of an experiment. I'll ask you to do this outline, and as long as you're telling me random assignments, the groups, the treatments, what treatments they're getting, online versus classroom, okay, and you talk about what you're comparing, that's what I'll be looking for. But a lot of times, if you don't like the outline, okay, you can also write about it. Instead of using this outline form, you can describe it using words, how you would actually do the random sampling, what treatments each of the groups will be receiving, and what you'd compare at the end. Alright, so to show you a couple examples here today. Here's the first one here. It says a health organization wants to know if a low-carb or low-fat diet is more effective for long-term weight loss. The organization decides to conduct an experiment to compare these two diet plans with a control group that is only provided with a brochure about healthy eating. 90 volunteers agreed to participate in the study for 1 year. Outline a completely randomized design for this experiment. Write a few sentences describing how you would implement your design. So I'm going to start with the outline here. Okay? So, how many subjects do I have here? Okay, so that's going to be the important part. So I believe it said 90 somewhere here, didn't it?
Yeah, 90.
90 volunteers. I was looking for the number, but they used the word. So I have 90 subjects. So now, what I want to do is I want to note that I am going to do a random assignment. Since it says it's a completely randomized design, I'm going to do some sort of random assignment, which I'll describe down below here in just a little bit. And I'm going to assign them to one of three groups. I'll just start by saying group 1, group 2, and group 3. In this grouping, I will want to note how many subjects in each group I want to put in. So, if I want to do it evenly, how many should each group get? Yeah, 30. Just simply 90 divided by, so I'll have 30 subjects for each. Now, each group is going to get a different treatment. So I want to note each of the treatments. What was the first treatment mentioned? Low carb. So treatment 1, I'm just going to put low carb. Now if you put another one, it's okay. I could have these in any order, but I need to note all 3 different treatments. So the next one will be treatment 2. This will be low fat. And then treatment 3, which was our control group, we could say control, and they actually got something, didn't they? They just simply got a brochure. Basically, here's how you eat healthy. So then, at the end, we're just going to compare our results. And we want to specifically determine what are they measuring here, okay? It'll be the weight loss of the subjects. Sometimes they'll be even more specific, where they'll say, we're going to measure the average weight loss, or we're going to look at the median weight loss. Does this outline system make sense? Are we okay with it? Not too hard? Just got to always make sure you're including all your key pieces in your outline. Now, it does ask you in this question, this is something that won't be on your test, but still, it's great to be able to describe how you would implement your design. And if I had to write a few sentences, what's nice about having okay, this flow, okay, chart is, I can use my flow chart to talk about how I would implement it. So, what I start off with is the random assignment. So I talk about how do I randomly assign these 30 subjects to the 3 groups. After I talk about the assignment, I talk about how they're given each of the 3 treatments, and then I, at the end, just note a sentence that I'm going to compare their weight loss. Okay? So, here's how I've described it at least here. So to implement this design, one of the ways we could do is to assign them, just do a random, instead of using the random number table, we could use 90 equally sized slips of paper. Yes?
Should we write all of this?
It's up to you. You can choose to, or you can choose not to. And you can do that with all your notes. Okay. Okay. So, the first couple sentences here is just talking about the random assignment. Mix them up in a hat. Have each subject draw a number. So we're putting 30 number 1s, 30 number 2s, and 30 number 3s in a hat, mixing them up. So when you walk in as a subject, you're just going to grab a number. Oh, I go to group 2, or I go to group 3, I go to group 1. Okay. Once they've all been assigned, okay, their specific type of treatment, then you want to talk about what you're going to measure. So here at the end of the year, the amount of weight loss will be recorded by each subject, and I noted that the mean weight loss will be compared of the 3 treatments. You could say the median, you could just say the total amount of weight loss compared by the 3 groups. That would be, though, could be a little bit, okay, even comparing the mean could be a little bit off, because you might want to actually compare maybe the percentage lost, because hopefully the random assignment will make sure that you have, equal groups of subjects in the different groups. But if you have a lot of very, very heavy people in one of the groups, okay, they might lose on average more weight than, if you have in group 1 a lot of people that weigh, say, 400 pounds versus 200 pounds in group 2, okay, they might just in group 1 tend to lose more weight. But hopefully the random assignment, okay, will distribute the people that weigh those weights differently. All right, any questions so far on the outlining of an experiment? Come on.
Oh, no, I'm just.
I thought you had your hand. Yes. Yes.
So you said we don't have to write all of them down?
For your exam, I will not ask you to do this particular part on the exam. You might still have this pop up in a question on, like, in your homework and stuff, so that's where this will be helpful for you. But for the regular stats classes, I will not ask you to do this portion. My AP stats class, they will be required to do this part. Okay? If ever asked about that on a question.
So the part that asks you to do this in this question, the part that says write a few sentences describing how you would implement.
Exactly. So you're talking about how you're actually assigning them,
Do that.
how they're, basically how are they assigned to their groups and receiving their treatment. Then what are you comparing at the end? So it's kind of similar to, you can think of this kind of setup similar to like what we did back in chapter 4.1 with the random number table, and we're assigning and trying to pick our samples. Here we're not picking a sample, we're assigning people to groups. So you could use the random number table here too. And
Assign people that you're going to
group 3, you could say, all right, assign each person a digit from 01 to 90. Okay, the first 30 unique numbers go to group 1, the next 30 go to group 2, and the next 30 go to group 3.
Would that make it like for sure when
Alright, anyone still on this page? Alright, let's go to the second page here. Give you a little more practice here. Number 2 says music students often don't evaluate their own performances accurately. Can small group discussions help? The subjects were 29 students preparing for the end of semester performance that is an important part of their grade. Assign 15 students to the treatment, videotape and practice performance. Ask the students to evaluate it, then have the students discuss the tape with a small group of other students. The remaining 14 students form a control group who watch and evaluate their tapes alone. At the end of the semester, the discussion group students evaluated their final performance more accurately. So, in question A says, outline a completely randomized design for this particular experiment. So, how many total students do I have here? 29 students. Okay. So again, we're going to have random assignment. So to group 1, which got, the first group got 15, okay? 15 students. And group 2 got 14 students. So now we have treatment 1 and treatment 2. So, when we're looking at this, the difference between the groups is they're all going to videotape and practice, but they asked the students to evaluate it, and then they had a small group of students. So in treatment 1, you had basically the small group evaluations versus a lone evaluation. So then we want to compare results. So again, what were they comparing? The evaluation of their final performance. So part B says, describe how you carry out the random assignment. This is something I would expect all of you to be able to do. Right? Because that is similar to, so if someone actually wanting to come in.
Yep.
Coming?
Yeah.
So, this is kind of this goes back to 4.1 where you want to label and table. So it says provide enough detail that a classmate could implement your procedure. So we want to talk about just this part here, the random, the random assignment piece. Okay? So, here I use the random number table since that is something that we have been using quite a bit. So I talk about assigning each student a 2-digit number from 01 to 29 in some way or fashion. I always like to say alphabetical order because it's probably the easiest way to do it with people since we have first and last names. So then I'm going to use the random number table, pick any line, so I'm not telling you a specific line, but pick any line, read off 2-digit numbers until you have 15 unique numbers between 1 and 29. Again, you're going to ignore 30 through 100 and any repeats. Because if student number 15 has been selected, you don't want to count them twice. Those students are going to go to treatment 1. The remaining 14 numbers that weren't selected go to treatment 2.
So this is something that would be only for AP statistics, right?
No, this would be something I would expect you to be able to do. Because this is similar to what we did in 4.1, where you're using the random number table, okay, where you label the students and then use the table.
Okay.
You know how, I'm not actually asking you to perform it, actually do the numbers, at least in this part of the question. I don't think this question actually asks you to, say, all right, carry it out for the first 3 students. That might happen. But the other part, unlike the previous question, is after you did this part, then what you'd have to describe is what you would compare at the end also on top of it.
Okay.
Does that make sense?
Yeah, that makes
Okay. So in the last question here, it asked, what's the purpose of the control group in this experiment? Why do you need it? What's the purpose of all control groups? Okay, to look for the differences. You gotta have something to compare it to. Okay, if I have, students all do this peer, evaluation where they they work in small groups and evaluate, how will I know they're doing a better job? I gotta have something to compare it to. So the purpose of that control group is to basically give you something to actually compare to and note whether there actually is some sort of improvement or not. In this case, are students doing a better job evaluating their performance? So like for myself as a teacher, some of you had me in Algebra 2. One of the things that I did last year was did a lot of videotaping of like the CFU practice, or I should say of all the homework assignments. Was something that I tried last year. And I tried a new teaching technique, and so what I would do was use my last year classes and scores and compare those to the following year's scores to see was there actually any improvement amongst the scores, and whether or not those scores are significant. The hardest part about doing that type of experiment though is there's many different lurking variables that can occur. So I'd at least try to compare 2 years ago's third hour scores to last year's third hour scores. So I'd at least try to take that into impact. But it's hard to, compare because students from one year to the other could vary differently by just ability. All right, so questions about our notes for 4.5. All right, I will turn it over to you, give you some time to work on your CFUs. Actually, you're going to have a good chunk of time here today. Doesn't always